David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today's topic, chi-square with 2 populations. So this adds a complexity to our chi-square calculation. However, it's a necessary complexity because this is what you're going to need to do when you analyze the data you collect for your POW research. So to summarize what brought us to this particular problem, you did the assignment delivering results. And in that assignment, you had to come up with observed numbers that supported Dr. Bertram's idea that she was better and her babies were less likely to be underweight than the other doctors. So you just had to come up with numbers. So I did my version of that in this table. Your version was different, undoubtedly, but it should be different in the same way that mine is. So I would like to go ahead and review those differences just so that we're on the same page. Okay, so you calculated the expecteds in a previous assignment where you were given your totals and you were given the total underweights and the total normal weights. And if there were no difference between these 2 groups, Dr. Bertram and the other doctors, then you can calculate your expecteds, and that's these values here, the 9.1, 65.9, 33.9, and 246.1. Those were calculated using the proportions that are evident here in the table on the outside. I also want to call your attention to another thing. I'm putting observed and expected right in one box. This is the format you want to use with your tables going onward. It's a 4x4 grid, just like we've been talking about in class, but I've now got 2 pieces of information in the center of my table. Okay? So I just made up observes that support her hypothesis, that she is better at delivering babies that are normal weight. So if she wasn't, you'd expect about 9.1 babies of hers to be underweight. I put 5. That's less than 9.1. That supports her hypothesis. And once you put that 5 in there, that determines all the other observes that you could have. Okay? So I picked 5, then 5 plus 70 have to be 75, so that worked. 5 plus 38 has to be 43, so that worked. And then 38 plus 242 has to be 280, so that worked. So just like when you calculate an expected, then you can get the rest by subtraction. When you determine an observed, you can get the rest by subtraction. Okay, so now we're ready to do a chi-square calculation with this table. And so I picked 5 as her observed underweight, much less than 9.1. So let's see what kind of chi-square that generates for us. So the chi-square calculation is just the same, except instead of having 2 terms, where you've got observed minus expected squared over expected, now you're going to have 4 terms. But other than that, it's the same process. So let's go ahead and do that. Each box generates one of the fractions. So let's do this first box. Observed, 5 minus expected, 9.1, squared over expected. Plus, let's do this one next. Observed is 70 minus expected is 65.9 squared over expected. Our third one, it's going to be 38 minus 33.9. So 38 minus 33.9 squared over 33.9. And then for our last one, it's going to be 242 minus 246.1. So 242 minus 246.1 squared over 246.1. So take a minute and look at that, compare it to the table, and make sure that that makes sense to you, how I did that. And of course, this is our chi-square equals all of that. Okay, now I want you to do is do that calculation. Get out your calculator, write down a few intermediate steps, and get your chi-square. Okay, let's see how you did. When I do it, I get a chi-square of 2.67. Okay? Now I want you to pause the video and determine how likely is the null hypothesis true. So you're going to have to look up that table. So pause the video, go look up that table, and then come back. Okay, I get about 10% probability. So 10% chance null is true. So what does that mean about the hypothesis? If you said it has a 90% chance of being true, you're right. So let's use some just normal human-to-human language to describe that. Her hypothesis is very likely true. Okay? I wouldn't say more likely true because 90% is actually in the very likely category. It's not close enough to 100% to be almost certainly true. That's stronger language. But I would be comfortable with saying that her hypothesis that she does a better job of delivering normal weight babies is very likely true. Okay, one last follow-up. When you finish the video, what I want you to do is pull out your work for delivering results and calculate the chi-square for the numbers you put in for observed and see what you get for your chi-square. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.